Hey guys, it's taken me all day to actually find a little bit of quiet so I can record this video for you. But anyways, this is the first foray into material you didn't see before we left school. So we're going to dive into section 8.6. But before we do that, I want to talk about what we've done so far in this chapter. So far we've used the Pythagorean theorem, special right triangles, and SOHCAHTOA, sine, cosine, tangent, to find missing parts of right triangles. And those methods are great, but they're great for finding missing parts of only right triangles. We use the Pythagorean theorem to find missing sides. After that, we used special right triangles also to find missing sides. And then finally, we introduced SOHCAHTOA, which we were able to use to find missing sides and missing angles. But again, these are all limited because they only work if we're talking about right triangles. So the goal of this section, actually, and we're going to do it over a couple of days, is to be able to find missing parts of triangles that are not right triangles. And today we're going to start with something called the law of sines. So the law of sines is an option if it is not a right triangle. But before we talk about what the law of sines is, I want to make sure we remember notation for triangles. Generally speaking, if we have angles named A, B, and C, the side opposite the angle is named with the same letter but the lowercase version. So side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. And the law of sines is basically just a big old proportion. So this is what it looks like. Sine A over side A. So opposites equals the sine of B over side B. Again, opposites. And you can imagine the third part, sine C over side C. And obviously we can't solve a proportion that has three parts, so we're going to pick the two parts that work for us. So we're going to do a couple of examples. The first, let me move this down so you can actually see it. We're going to find P, so this side over here, round it to the nearest tenth. So obviously this has PQR instead of ABC, but you can imagine the sine of P over side P must be equal to the sine of R over side R, which is also equal to the sine of Q over Q. Now we have this angle and the opposite side. So we have this part. We have this angle, but we don't have the opposite side. So that's probably not going to be of much use to us. And we also have this side. And we can easily figure out this angle up here by subtracting from 180. So if I do 180 minus 29 minus 17, and I'm going to grab my calculator so that I don't make any stupid math errors on my video. It's 134 degrees. So this angle is 134. So the two parts of this formula that I'm going to use are these two parts. I don't need to know what side R is, so I'm actually just going to take this part right out of the equation. And now I'm going to substitute everything in. So the sine of P, angle P is 17. So sine of 17 degrees over side P, that's our unknown, equals the sine of 134 over the side opposite. So that might look a little scary, but if you remember, the easiest way to solve proportions is to cross multiply. So I'm now going to cross multiply 12 times the sine of 77 equals, and now I'm going to go the other way, P times the sine of 134. So it already looks a little bit better, but I've got one more step, and that's to get P by itself. And again, I'm doing all of this manipulation before I touch the calculator. So to get p by itself, I'm going to divide both sides by the sine of 134. And now you should be able to just type that entire expression into your calculator. And I'm going to attempt, I don't know if I can fix the glare here. Hopefully that'll work. But my goal here is to type in 12 times the sine of 77. And at this point, if you're using a phone calculator or something else, either make sure you close the parentheses or hit enter before you divide by sine 134, divided by the sine of 134. And I might as well close those parentheses also. And I'm going to hit enter. And I get that P is about 16.3. And that's it. Let's try one more just to make sure we're good. Get this back up here so you can see. Okay, so same idea. This time we've got A's, B's, and C's. Doesn't really matter, but I can see pretty quickly that I've got this angle and the side opposite. So I'm going to do the sine of 50 over the side opposite equals, and now let's see if we have anything else that matches up. I've got this angle, but I don't have this side, nor do I need it, so I'm not going to worry about that. But I do have this side, so I'm going to use this angle over here, which means I need to figure out what its measure is. And I'm going to do the same thing that I did on example 1. I'm going to subtract 50 and 57 from 180. And I get 73 degrees for angle C. So now I can go up here, and it's the sine of 73 over 6. And now I've just got a proportion. Cross multiply. So 6 times the sine of 50 equals x times the sine of 73. To get x by itself, we're going to divide by the sine of 73. And again, I'm just going to grab my calculator, pull it in here. Hopefully you can see the screen okay. I'm going to actually turn this light off up here and see if that helps or hurts. Maybe it's a little better. You guys will have to let me know. So I'm going to type this in right here. 6 sine 50, close those parentheses, divided by the sine of 73. And I get about 4.8. So there you go. We've got one new method that we can use to find the missing sides of not right triangles. We're going to practice that a little bit for homework today, and maybe we'll do a Google Meet. I'll post a link, and you can join that tomorrow. If you have questions, we can do a few together. But then tomorrow, I will introduce you to the law of cosines, which is a little scarier to look at, but not that much scarier to do. So that's it for now. Thanks, guys.